In today's video, we are going to learn about linear shrinkage. These are the equipment. These are the spatula, the cup will help us. That is trough or the mold, shrinkage mold. We are going to use it. And then that is our cone penetrometer. Now we have the sample and the water and the glass plate. That's where we'll be mixing our sample. So linear shrinkage is the decrease in length of soil sample when it dries from its wet state to a dry state. It's an important property used in geotechnical engineering to understand how much a soil will shrink, especially clay soil. Now, we mix the soil sample well, uniformly, until it attain a homogeneous paste. Then we use our cone penetrometer method. That's a cup. We have tapped it in a firm ground or a rubber so that we can remove all the air voids. Now we have attained 19.7. That's around 20 millimeter. So we take them. That's 20. That's moisture we have taken, but the main thing here, we want to take the shrinkage, taking it at around 20 mm. 20 mm. After filling the mold, we tap the mold until we tap it on the firm ground out there on the bench until there are no more air voids. The reason we have used the 20 mm is because it represents the state where the soil transitions from a plastic state to a liquid state. So we let the wet sample to dry for some time, then we put it in the oven, then removed it after 24 hours. Now you can see it is already dry. Then we will measure the length. The length of the mold, this shrinkage mold is 14 centimeter, which is equal to 140 mm. Then we note the shrinkage length now. So then we do a calculation. So what we've gotten here is 1.5 centimeter, which is equal to 15 mm. And then the whole length is 14 centimeter, which is equal to 140 millimeter. Then you multiply it by 100. Yes. So 15 over 140 times 100, we get 10.7%. That's our linear shrinkage. So linear shrinkage helps us understand soil behavior during drying, and especially important for clay soils in construction project. See, now that's the whole mold now. Just showing